Hi there, this is Professor Monty, and we're finding the payment amount that we have to make for an annuity. So if we know the amount at the end that we want for the annuity, how much is the periodic payment we have to make? Remember, an annuity is a periodic payment that we make into some sort of an account. So I've got the formula there. PMT stands for the payment amount. And then we have the rest of it. A is the amount at the end. R is the rate of interest. N is the number of periods per year that both the money is compounded and we make our deposits. And T is the time in years. Those other numbers are just ones. It says, how much should you deposit at the end of each month? So N equals 12. Into an IRA that pays 8.5% compounded monthly to have $4 million when you retire in 45 years. And how much of the 4 million comes from earnings? Okay, so we're going to use this formula. We're going to plug things in. I'll show you how to do it on the calculator. So A is the amount we want to end with. That's $4 million. 4 with 6 zeros. Parentheses. R, the rate of interest. Well, it's 8.5%. To move the decimal 2 places to the left, it's 0.085. And then divided by N, remember that was 12, raised to nothing. Let's see, divided by bracket parentheses, 1 plus that same 0.085 divided by 12 to the NT. Well, N was 12, T was the number of years, 45. I'm going to put a parentheses around there. Some calculators, such as mine, actually raise that into an exponent, and so you don't have to use the parentheses. Some don't physically raise it as an exponent, so you do have to use the parentheses. I'll just put it with the parentheses so it works for everybody. And then -1 outside of the parentheses. Then we'll close the bracket, which is parentheses on the calculator. So that's what I'm going to put in. You can do separate pieces and then put them together. I like to do it all as one big piece. If you learn how to do it all as one big piece, you don't have to write down intermediate steps. You don't have to make sure your decimals are going to the right number, any of that stuff. I'll show you how I'm going to do it, and then I'll pull up the calculator so you can actually see me doing it. So here's what I'm going to put in. So for payment, I'm going to type in $4 million, left parenthesis, 0.085 divided by 12, close parentheses, and then divided by now the whole denominator. That's the bracket on the left and then the parentheses. So 2 parentheses, 1 plus 0.085 divided by 12 again. Close that parenthesis, raised to the power. Some calculators look like x to the y, some look like y to the x. Mine looks like this little caret. Parentheses, 12 times 45. Close parenthesis, minus 1, close parenthesis again. That's what it's going to look like. Let's put it into the calculator and see. So you pull up the calculator. We got a TI-85 plus calculator emulator. Let's type everything in. $4 million, left parenthesis, 0.085 divided by 12, close parenthesis, there's my whole numerator, divided by now for the whole denominator. And then the stuff, the 1 plus that's inside, another left parenthesis, 1 plus 0.085 divided by 12, close that parentheses, raised to the power. See, mine goes up as an exponent, some don't. Left parenthesis, 12 times 45. Close that parenthesis. Since I'm up as an exponent, I have to arrow out of the exponent. And then -1. Close parenthesis again, equals, there's my payment. Now, the book that I got this out of says round up to the nearest dollar. So we'll round that up to $641. So my payment, $641. That's what I have to deposit per month. And it says how much of the $4 million comes from earnings. Well, the earnings are going to be what we end up with, ending amount minus what we deposit. So the earnings, well, we ended up with $4 million. Minus, let's put this in parentheses, we deposited $641, 12 times a year for 45 years. So we get 4 million minus, if I put this into my calculator, 641 times 12 times 45, I get $346,140. I was doing a double take because it doesn't seem like very much money. Because notice if I subtract that away from the 4 million, my earnings are $3,653,860. That's all earnings. I only deposited $346,140. I ended up with $4 million. So I ended up with an extra $3,653,860, where I wouldn't have had if I just kept that money in a shoebox someplace, for instance. So that's the power of compounded interest. So hopefully that helps. Try to do this all as one step like I did in your calculator. I think that'll really help you out. And it just takes a little practice. And remember, you can do this.